Welcome to lesson 53. I get to show you something a little bit fun today. Before we get to the fun, we have to have a different kind of fun, and that's let's count. Let's count from 0 to 7. We can do that, especially if you do it in the octal system. Because remember, the octal system, which is base 8, you're allowed to use 8 different symbols, which means we can use the symbols from 0 to 7 to count to 7. And so actually that was quick. So in the octal system, that's what it looks like to count from 0 to 7. It's a little more challenging to do that in binary. For one thing, you're going to need a few place values here, right? So 0 would be 0, 0, 0. Now think back to the odometer, the binary odometer. When you go when you go a mile, that 0 on the right becomes a 1. So that's what a 1 looks like. And then there's only zeros and ones in binary, right? Only 2 faces per dial, zeros and ones. So this wheel on the right, which is a 1, has to turn back to a 0. And then there's like a little tab or whatever that'll catch the next wheel. Whenever you turn back to a 0, it catches the next wheel and makes it spin. So that's going to have to go from a 0 to a 1. Okay, so that's what a 2 looks like. And by the way, that's the 1's place. That's the 2's place, right? So that's why that's a 2. It's got a 1 in the 2's place and nothing else. You want to go 3? Well, that 0 is going to spin to a 1. And then you want to go to a 4? Well, that 1 is going to go to a 0, and every time you go to a 0, you pull the next wheel. Now this wheel is going to go to a 0, which means it's going to pull the next wheel. And there's a 4. And again, I invite you to remember, this is the 1's place, this is the 2's place, and 2 times 2 means this is the 4's place. So if you got 1 in the 4's place and nothing else, then you got a 4. Okay, so there is a logic to this. And then this 0 is going to go back to a 1, and then this 1 goes back to a 0, which pulls this wheel, and then the 1 goes to here, and that's as far as we can get without opening up a 4th spot. But we don't have to go any further. That's a 7, again. That's in the 1's place, that's in the 2's place, that's in the 4's place. You got 4 plus 2 plus 1 is 7. Cool. You should be able to do that. When we have the test in class, I always require people, the very first question on the test is to generate this table, which means you're going to need to be able to count by binary. No, I don't give you this table. You generate the table. You can build it yourself. All you guys, well, you can count from 0 to 7. I know you can do that already. So it's just a matter of getting this table figured out. Actually, notice there's a nice pattern here. 0, 1, 0, 1, 0, 1, 0, 1. Now go look at the 2's place. 0, 0, 1, 1, 0, 0, 1, 1. Now look at the 4's place. 0, 0, 0, 0, 1, 1, 1, 1. Pretty cool, right? Okay, how do I erase? No. How do I erase only the green? Only the green. Okay, well, I did a pretty good job. Okay, so there we are. We have our nice little table here. Okay, now, we'll come back to that table in a minute. First, let's go back and review converting like we were used to do. Actually, I'm not sure we've done this very much. From binary to octal. I think if we go back like 2 homework assignments, I had you go from binary to decimal, and then from decimal to octal, right? You could do it that way. It's kind of like a 2-part problem. Go into the decimal first and then into the octal. But this is a special number. We're going to be able to do this one a little bit more easily. First of all, keep in mind, octal means base 8. They're asking us to write into the octal. That means write into a base 8 system. 1's, 8's, and remember, base 8 means times 8 64s. Probably won't need to go higher than that. So we're going to be writing into this place value system, the octal place value system. Now let's take a look over here at what we've got. This is written in binary. This has been written by filling in base 2's, which means, well, that's always the 1's place, but then that would be the 2's, that would be the 4's. This would be the 8's, times 2 is 16's, times 2 is 32's, and then we've got a 64. Okay, so notice we've only got a 1. We got a 1 in the 64's place, and we got a 1 in the 16's place, and we got a 1 in the 8's place, and then we got a 1 in the 2's place, right? Everything else is a 0. I don't have any 1's. I don't have any 4's. I don't have any 32's. What I've got is a 64, a 16 and 8, and a 2. Okay, let me get this out of the way now. So now let's go over here and say, okay, how many 64s have I got? Just that one. I've got a 64, see? How many 8s have I got? Well, actually, I got a pair of 8s there plus another one, right? The 16 is like having 2 8s. The 8 makes a third 8. So I got 3 8s. Huh? And then I got these couple of 1s kicking around, 2 1s kicking around loose. So there it is. There's my octal number. Now that wasn't so bad, right? Well, you ain't seen nothing yet. Here's what I want you to dig. Notice that, let's see, I need a really good color here. Notice that where we got this 2 was by looking at this part of the number. We had a 1 in the 2's place, which gave us 2. And where we got the 3 8s was we had something in the 8's place, and then this is the 16's place. We had an 8 plus 2 16s, right? If you look at this 0 1 0, that is a 2. Huh? And now, if you look at this 0 1 1, that's a 3. Huh? Do you see what's going on here? And then over here we've got, it says a 1, but think of it as like a 0 0 1. So a 0 0, it says example 1. Don't let that one get in your way. Okay, so we've got a 0 0 1, which is a 1. Huh? Do you see the nifty-difty shortcut? Here's the nifty-difty shortcut. I'll show you on the next example. What you do, first of all, notice, oh boy, I have to try to erase these again without erasing the actual numbers, please. Please. Oh! Try that again. Oh! Try that again. Ha ha. Ha ha. Oh! Okay. Here we are. So what was I saying? Oh, I was saying, yeah, in the binary column, we've got 3 digits, right? So you grab 3 digits at a time to turn it into something octal. Grab 3 digits at a time. So you look at example 2 here. Now, this is binary. I'm going to grab 3 at a time, like this. Groups of 3. And then all you guys do is look up here to your table and say, what's a 110? A 110 is right there. A 110 is a 6. So I'm going to write a 6 there. And then you say, well, what's a 100? So you come up here and you say a 100. Well, that's a 4. So I come down here and I put a 4. And now you say, okay, what's a 010? There's a 010. It's a 2. So you put your 2 here. And then finally, we've got a 101. So you come up here and you go 101. That's a 5. This is what we call a shortcut. This is what I call, anyway, the binary to octal shortcut. So this table, we got octal over here, we got binary over here. You can use this table to go back and forth between octal and binary in a lickety-split kind of a fashion. It's a really nifty shortcut, just the niftiest thing in the world. Let's try it again on this one. Now the thing to keep in mind, this number here was nice, right? I had groups of 3. I had 4 groups of 3. It came out nice and even, right? The thing to keep in mind is please do not do this. Do not write this down because you do not do this. You don't go like this, cut off 3, and I only got 2. No, you don't do it that way. What you do is you start at the right. Very important. So you count off 3 this way, right? There's a group of 3. Then you count off 3 more. There's a group of 3. And then you can always stick a 0 in front for free, right? And there's another group of 3. So you always want to start at the right when you're grouping off by 3s here. Having done that, we can just kind of say, okay, I got a 0, 1, 1. Do, 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 do. 0, 1, 1 is a 3. Do, 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 do. That's a 3. Now I've got a 1, 1, 1. Do, 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 do. 1, 1, 1. That's a 7. Do, 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 do. 7. And then finally I've got a, what happened here? That was a 3, that was a 7. How'd this get over there? I'd like to know how that got over there. What's going on here? 0, 1, 0. That's not a 3, that's a 2. What the heck did I do? How did I do that? How did I do that? Start over. We'll have to trim that from the tape, right? So you look at this and you say 0, 1, 0, a 0, 1, 0. That's a 2 right there. That's a 2. Come down here and say 2. And then you say 1, 1, 1. Coming back up here. 1, 1, 1. That's a 7. So put a 7 in its place. And then we go like this. 0, 1, 1. Come back up to here. A 0, 1, 1. That's a 3. So this is a 3 right here. And there's your octal. You can put a little 8 on there if you want to be official. Put a little 8 on there to be official. Put a little 8 on there to be official. Okay, so you got to admit, that's a cool little shortcut, right? So examples 1, 2, and 3, we had our binary. We went to octal. So what we did is we took our binary, split it up 3 at a time, and went to octal. If you want to go the other way, it's a similar kind of game, except this way, except this time, I should say. These are the octals, right? That's what the 8 says. These are the octals. So 3 is the octal. So you're looking at this table in a different way. You're saying, oh, 3 is the octal. So the binary that I get, because I'm going to binary, the binary that I get is 0, 1, 1. The 6 is octal. I know it's octal, it says it right there. The 6 is octal. So I take the 6 in the octal column, and the binary is a 1, 1, 0. And then the 5 is an octal. The 5, when I go to binary, becomes a 1, 0, 1. And there's your binary. Now this, you can cross that first 0 off. Put a little 2 there for emphasis, maybe. Okay, the leading 0 is kind of optional. You don't really need it. But there you go. There's your binary. And if you want to verify it, you certainly can. You know, convert it to, maybe convert both to base 10 or something just for fun. Here's one, another one. So this is the octal. These are octal digits. To go to binary means I'm going to use this table again. I'm looking up the octals and turning them into binaries. So I'm going to look up a 7, 3, 4, 2. I'm going to look up a 7, 3, 4, 2. So the 7 is a 1, 1, 1. And the 3 is a 0, 1, 1. And the 4 is a 1, 0, 0. And then the 2 is a 0, 1, 0. And now you're done. Ain't that slick? Well, if you think that's slick, that you can go from binary to octal, well, then let's talk about hexadecimal for a little while. Of course, we'll have to count again. Now, counting in hexadecimal, we're going to go up to 15 this time. So counting in hexadecimal, well, if you want to go from 0 to 15, you start with 0. You use like an actual pen. And you start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, we had to, for number 10, we had to use an A, and for an 11, we had to use a B, and for 12, a C, and for 13, a D, and for 14, an E, and for 15, this is 15 here, we would use an F. If you got to 16, that's what a 16 looks like in hexadecimal. But we're not going to 16, we're going to 15. Now in binary, we're going to need to use 4 digits. You can start with all zeros. And like I say, on the test, this is actually your second question, is to generate this table from memory, just being, or not even memory, but just being able to generate yourself by counting in binary. Go from 0 to F, and then in binary, keep that wheel on the right spinning. That goes back to 0, which pulls that wheel. 1, 1. This wheel goes back to 0, which pulls this wheel. It goes back to 0, which pulls this wheel. There's a 4. 5, 6, 7. And remember, an 8, you know you're in good shape if this is what an 8 looks like, because what you've got is that's your 1s, that's your 2s, that's your 4s, that's your 8's place. So you've got a 1 in the 8's place. That's a great way to make an 8. Adding 1 more is a 9. I always thought this was kind of funny. That's what a 10 looks like in binary. A 10 looks like a 10-10. Be that as it may, there's an 11. There's a 12, keep the wheel spinning. There's a 13, there's a 14, and here's what a 15 will look like, right? And again, I point out this pattern. In the 1s column, we go 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. In the 2s, we go 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. In the 4s place, we go 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. And then in the 8th place, we go 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. It's a cool. Oh yeah, now I have to figure out how to erase this. Oh, I did it. There we are. So I wonder if you can guess what our shortcut's going to be. Well, let's look at example here where it says dig. Well, this is binary. That's nice. So notice we got a 1 in the 2's place. That's the 1s. We don't have anything there. We have something in the 2's place. That's the 4s. We have something in the 8's, something in the 16's. There's nothing in the 32's, and then there's something in the 64's. Okay, so that's what we got there. We got a 64, a 16, an 8, and a 2. We're filling hexadecimal, which is base 16. We're filling up a base 16. So we got a 1's place, we got a 16's place. 16 times 16 is way more than we need. We don't have 256 here. The highest we go is a 64. Okay, so let's think about this without taking any weird shortcuts. Let's just think about this by looking at our numbers. How many 16s can I get from up here? Well, those don't count, but I've got a 16 there. And then the 64. Do you know how many 16s go into 64? It's exactly 4 of them. So I got 4 16s plus another one. I got 5 in the 16s place. I got 5 16s. Now I've got an 8 and a 2 makes 10. I got 10 to put in the 1's place. So that's going to be an A. And there you go. It works. Or you can take the shortcut. Let's take a green shortcut. With hexadecimal, because we have 4 digits here, you would chop off 4 at a time, starting from the right. Starting from the right and going to the left. Just like when you're putting commas on a number, you start on the right and you go back 3 comma, back 3 comma. Well, here we're starting on the right and we're going back 4, slice. Back 4, which means I'll put another 0 there, slice. Notice I've got 2 digits. I've got a 0, 1, 0, 1, which is where? 0, 1, 0, 1. There it is. That gives me a 5. We knew that. And then I got a 1, 0, 1, 0, which is right there. Gives me an A. We knew that. So the answer to this one is 5A. And if you want to be explicit about it, put a little base 16. Okay, so the only difference, we're doing the same kind of song and dance as we did on page 1. But with octal, we did groups of 3. With hexadecimal, we do groups of 4. Now these are shortcuts to get to and from binary. So binary to octal, binary to hexadecimal. Let's see, where's our next example? Way up here. Okay, you ready for this one? We want to go into hexadecimal. So let me kind of do this. Going into hexadecimal? Seriously? Okay, we're going into hexadecimal. Yeah, okay. I'm good. I'm normal. Going into hexadecimal, which means we're going to want to be going this away wise, right? We're going to be wanting to make movements like this. This is the binary. So I'm going to want to go binary to hexadecimal. I'm going to want to take groups of 4 and turn them into one digit each. So start slicing off your groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, this comes out nice and even. 4 groups of 4, 4, and 4. Now, a 1, 1, 0, 1 is going to give me a D. A 0001 is going to give me a 1. And a 0101, where's that? That's here. That's going to give me a 5. D15, D15. Put a little 16 there if you want. That's all you got to do, folks. 4 at a time. Hexadecimal again. We want to go into hexadecimal, which means, once more, we're using the table trying to go that away. So we're going to take groups of 4, slice, slice, and go look it up. 1011, that's a B. 1011, how do you like that? That's a B. I wasn't expecting that. So we got BB. BB. The answer to that is BB. Now always pay attention to which way you're going. Here we want to go into binary. So if you look at the way this table is set up, going into binary means you're trying to go to the right. So you're going to take every 1 digit is going to become 4. So this 3 is going to come into 4 digits. So what's a 3 become? A 3, let's get this out of the way. A 3 should give me a 0011. 0011. Then you grab the 6. And the 6 is going to give me a 0110. And that's important to get all 4 digits down, the 0110. And then I end with the 5, which is a 0101. 0101. And then if you want, you can cross off those 2 at the beginning. We don't really need those. And just write it this way. There's our binary version of the hexadecimal 365. You're grooving on this. Maybe you should do this last one. Or it's not the last, but the last one on this page. Okay, again, we're going from hexadecimal into binary, which means we're going basically in a rightward direction using that table. Each digit's going to become 4. So what does a 7 give me? A 7 is going to give me a 0111. 0111. And then a B is going to give me a what now? A B is going to give me a 1011. 1011. And then I do an F. And an F is going to give me a 1111. Make sure you get 4 of them. Make sure you count correct. Again, we don't need that 0 in the front, so I'll just kind of leave it off. Boy, look at this thing. Well, that's what you get. That's what you get. That's what you get. There it is, binary. Ooh, fun. What's the next one? Oh, yeah. So now, 2 pages down, just 1 little page to go. So we've seen the nature of the binary to octal. We've seen the nature of binary to hexadecimal. You got to admit, those are slick. Very, very slick shortcuts. Now, what's this doing? This is a little bit different, you'll see, because this is asking us to go from base 16 into octal. We haven't done that. What we've done is we've gone binary to hexadecimal, binary to octal, but never straight hexadecimal. Well, go through binary. In other words, page 1 gave us page 2, let's start with page 2. Page 2 gave us a way to go from hexadecimal to binary as a shortcut, and then page 1 gave us a way to go from binary to octal as a shortcut. So we're just going to have to do the problem twice, but both times as a shortcut, so it's not going to be that bad. So first, starting with this base 16 stuff, that's a 3 in the hexadecimal. Hexadecimal because that's a 16. That's a 3 in the hexadecimal. Come up to my hexadecimal table and say 3. 3 is a 0011. So I start by writing the 0011. Then the E, oh, it's only a 2-digit number, this is good. Then the E, which is a 1110. 1110. Okay, there I am in binary. So I made it from hexadecimal to binary. Now to get from binary to octal, remember the first page we had groups of 3. So starting at the right, I come back 3, chop, I come back 3, chop, and well, that's just a 0, that doesn't count, right? So we're going to have a 2-digit octal number, it looks like. So now you go to the page 1 and you say, what's a 111? Way up to page 1. A 111 is a 7. So that's a 7. That's a 0, of course. We don't really need to write that. But that's a 7, and then a 1, 1, 0. I invite you to go look it up yourself. It's a 6. And so the final answer is this is a 7, 6 in the base 8 system. So that's not so bad. So we went from hexa to binary pretty quick, and then from binary to octal pretty quick. And so if you want to go from between base 8 and 16, one way or the other, just go through binary using the shortcuts, using them twice. Here's one where we're going to go the other way. Here we went from 16 to 8. Here we're going to go from 8 to 16. Oh, give it a try yourself. We're running out of lecture here. Why don't you give that one a try? Have you tried it? Well, all right then. So going back to page 1, groups of 3, right? So let me write a map over here. So to go from octal to binary, and then from binary to hexadecimal. Again, if you want to go between octal and hexadecimal, you got to go through binary. Now, octal to binary is groups of 3, and binary to hexadecimal is groups of 4. That's the two main things to remember. I remember it this way because 8 is 2 to the 3 power and 16 is 2 to the 4 power. But however you remember it, it's groups of 3 to get from octal to binary. It's groups of 4 to get from binary to hexadecimal. So the 7, you look up the 7 on the octal table and it turns out a 7 looks like that. And if you look up the 3, it looks like a 0, 1, 1. Okay, so that's my octal. Boom, now it's binary. Put a little 2 there if you want. Now I want to go groups of 4. So I come back like this, and then I can come back like this. And now I look up these two pieces on my hexadecimal table. And it turns out this is a 3, and this is an, well, it's an 11, which is actually a B. So this is a 3B in the hexadecimal system. I'm going to double check that. 1011, 1011. Yep, it's a B. Yep, B. Good, B. That's a 3B. Okay, so now I just have this little conversion map. So it's kind of like what I wrote here, except let's be a little more official about that. So I'm going to put binary right in the middle, because sometimes we go through binary to get to something else. So we know that we have a shortcuts that we can take to go back and forth from binary to octal, right? I'm drawing the double arrow to say there's a direct way to convert either way, from binary to octal, octal to binary, and it has to do with using the table on page 1 and grouping them off by 3s. There's also, on page 2, a nice way to go back and forth between binary and hexadecimal. And that's involving groups of 4, right? So if you want to go from octal to binary, do that. You want to go from octal to hexadecimal, do that and then that. You want to go from binary to octal, do that. You want to go to hexadecimal to binary, do that. You want to go hexadecimal to octal, do that and then that, right? So now you're saying, well, how come you didn't show us this in the first place, man? You're going to save us a lot of grief. And it's like, well, no, I had to show it to you because notice there's no shortcuts to decimal. If you have any conversion problem that involves base 10 in any way, whether you're converting out of base 10 or into base 10, there are no shortcuts. You have to use the place value systems. So that's why we had to practice that, is so that now we can go from base 10 to hexadecimal, base 10 to binary, base 10 to octal, or the other way, octal to decimal. You know, no shortcuts. You got to use the place value system. So we might as well not even have arrows because there's no direct link. You have to use the place value system. Okay. So now I think that's going to finish the whole darn topic of number systems. We've seen our binary, we've seen our octal, we've seen our hexadecimal, we of course know decimal. Now we can convert between any two of them because we got the shortcuts and we got the roadmap. We're good, we're golden. Let's stop somehow.